Hey everyone, this is a video for Unit 5B, Target 4, which is about common and natural logarithms. Shouldn't take too long, so hopefully this is a quick video and you can get started on your homework when you're done. All right, so today we're talking about two additional versions of the logarithm. We've got the common logarithm and the natural logarithm. So let me see if my stylus is working today. The common logarithm is basically when you have a base of 10. So a common logarithm would be something like log base 10 of, let's say, x equals y. But because it's so common, most people, including your calculator, write it as just the word log with no base, and then you just say log of x equals y. But when there is no number down there in the base, so nothing here, it means that the base is 10. So either one of these equations would be rewritten as 10 to the y equals x. Okay, now the natural logarithm is one that occurs, surprisingly enough, in nature. It's used also a lot in finance, in banking. It's a common base that is used in places. In a lot of places, it's just not as easy to work with. So the base of the natural logarithm is the number e. And I don't know if you've ever seen that button on your calculator with an e there, but if you press the button E and then just hit enter with just to the first power, and it's going to be about 2.71 and a whole bunch of other decimals afterwards. So the number E is approximately 2.71, and it is the base of the natural log. And we write the natural log as ln. So you say ln of x equals y. This is really just the same as saying log base E of x equals y, which really it is just then just another way of writing the base of e. And this is also a button on your calculator. So the natural log is on your calculator. Now it seems weird that we call it the natural logarithm, but it's ln. It's actually it came from a French mathematician, and they would have said logarithms backwards than us, and they would have said logarithm natural. I don't know how you would spell it in French, but that's kind of where it would have come from. And this logarithm with a base of e is then written in exponential form as e to the y equals x. Okay, so we're going to practice today with these two. So part one, we're going to rewrite these in their equivalent logarithmic form. Excuse me. We're not solving anything, we're just rewriting it. And if the base is 10 or the base is e, then we just use either the common log or the natural log. So this is base 10, which is the common log. So it's going to be rewritten as log of 100 equals 2. Now this one over here, it's going to be log of 150 equals x. So let me remind you, in case you've forgotten, that when you have log base anything, so log base b of x equals y, the equivalent exponential form is b to the y equals x. So for this problem right here, the base was 10, the base is 10, the base is 10. We just write it with nothing here. The power, let me look over here. The power is the answer. So here the power is y, the answer is y. So this power is x, it's the answer. And then the number on this side over here, this in case it's x, becomes what's called the argument and the log. So just as a reminder, that's how that works. Okay, this one has base e. So this is the natural logarithm. So you would just say natural log of 54.598 is equal to 4. And if you were to type any of these in your calculator, literally take this and put it in your calculator and see what you get as an answer. And then this one becomes the natural log of 35 equals x. Okay, so that's the first part. We're just writing it from exponential form into log form. So then, of course, we're going to go the other direction. We're going to take the logs and write them in exponential form. So same thing, we're going to use that rule from the previous screen. Oops. Let's change that color back. Let's do red this time. So this first one is base 10. So this is going to become a 10 to the power of 1.732 equals 54. The base raised to the answer equals the inside part. Okay, now this base is e. So we're going to do e to the answer, e to the 1.609 equals 5. And again, and I'll open the calculator in a second here, but if you were to, well, you know what, I'll just do it right now. If you were to type that in your calculator, you're going to see that that's approximately the answer. Okay, while we're waiting, let's rewrite these next two, and then I'll take out that calculator. So this one is the common base. So this becomes 10 to the x equals 26. And then this one is the natural log. So e is the base. So e squared equals x. So let's get that calculator here. So that problem that we were just looking at was e to the 1.609. So I'm going to type that in the calculator. So e is above the natural log. So you hit second natural log. So there's e, and it was to the 1.609. Okay, so it's 4.998 because this was rounded, right? So it's a little bit off, but pretty close. And then the other one was a log base 10. So here is our log base 10. So I'm going to do 10 to the 1.732. So 10 to the 1.732 gives us that 53, or about 54, or vice versa. I could do log of 54, type that right in the calculator. So here's log with no base. Log of 54 gives us that 1.732. Okay, moving on. So go to the back. Now you're going to do literally what I just showed you. We're going to do what I just showed you on the calculator, but we're going to do it without the calculator. So we want to remember that these all have bases that are kind of hidden, right? And really when we're trying to evaluate, we're going to set each problem equal to x. So we're going to just make an equation out of these and solve each of them for x. So these first ones here are all base 10. If it helps you, rewrite the 10 in there if you need to. Hopefully eventually you won't have to. So I'm going to take and put this in exponential form. So I have 10 to the x equals 10. Well, how can I have 10 to the x equal 10? Well, the power on this 10 would have to equal 1. So that means my powers are equal. So x equals 1. All right, we're going to do the same thing with this number 10 over here. So I'm going to rewrite it as log base 10. And I'm going to take that 1/10 and I'm going to rewrite that as 10 to the negative 1. So remember, when you have a negative power, it can be rewritten as a fraction, or a fraction can be rewritten with a negative power. Now I'm going to rewrite this in exponential form. So the base raised to the answer. So 10 raised to the x power equals that inside part equals 10 to the negative 1. Since the bases are the same, the exponents are equal. Okay, next one, I'm going to do the same thing. Oops, let me scroll down. So I have log base 10, and then that radical 10, I'm going to rewrite as 10 to the 1/2 power. So I'm going to use my knowledge of rational exponents. This is a rational exponent. So radicals become these fractional exponents. Now I'm going to rewrite it. 10 to the x equals 10 to the 1/2. Powers are the same, or powers are equal because the bases are the same. So I get x equals 1/2. Now, at some point in time, if you get good at these problems, you don't actually have to do it as an equation and you don't have to rewrite it. So I'm actually going to do this next one that way. So I'm going to think of it with base 10 and I'm going to rewrite 100 as 10 squared. If the base of the log has the same base as that argument that's after the log, so if those two things are the same, then that means that the answer to the problem is just the power. So the answer here is 2. Now, if you didn't remember that, or that doesn't make sense, then you go ahead and you rewrite it as equal to 10, and then you rewrite it in exponential form, so it becomes 10 to the x equals 10 squared. So the powers are equal, so the power of 2 is the answer. All right, 4 more. Here we go. Okay, I think we just did that problem, didn't we? Literally, it's the same one twice. So I guess my bad on that one. No, these are all interesting. Looks like your paper is different. So, strange. Let me go back. I want to see here. So over here, 9, 10, 11, 12. Oh, I see what I did. Sorry, you guys. I cut and pasted. So they're the same because it's the same exact problem. So to have a little laugh on me, and I'm going to scroll down and just do the 2 problems that are here, or the 4 problems that are here. Okay, here we go. So again, if you want to, set them all equal to x. But the E ones are actually a little bit easier because most of the time you're not going to see it as a number. You're not going to have to do much changing. So if the base, as I just said before, if the base, which is E, and the argument are the same base, then the power on the argument, which in this case is 1, is the answer. So this is just equal to 1. But if you don't like that, you do e to the x equals e. You got to put that little power on the e, and there is power x equals 1. Okay, so hopefully maybe this problem you don't have to do with it equal to x, and you can just tell that this power is the answer because the bases are the same. So the answer here is 7. This one I need to rewrite as e to the 1/4 power, which literally means that 1/4 is the answer. And then for this one here, I'm going to rewrite it so that it's e to the -1 power, so that you can go, oh, the bases are the same. So that means that the exponent on that argument is the answer. So this is -1. But again, you can do this. So it's e to the -1 here equals x. So your base over here is, oops, sorry, the base. So what happens when you work from home? Okay, so the base over here is e. So this becomes e to the x equals e to the -1. So -1 equals x.